Okay, some things you should know about DNA. DNA is a double helix, so there are two strands. This is one strand, this is two strands. It's made up of repeating units, phosphate in purple, deoxyribose sugar in red, phosphate, sugar, phosphate, sugar. Phosphate's negatively charged, and so DNA has a negative charge, and we use this when we carry out electrophoresis. In the centre are the bases, A and T, and C and G. A always bonds with T, C always bonds with G. Okay, so an A and T base has two hydrogen bonds, 1, 2. C and G, by contrast, has 3, 1, 2, 3. This has practical implications if you're carrying out PCR, for example. If your primer has more C's and G's, it will anneal a bit more readily if it has more A's and T's. The structure of DNA leads to a major groove. So you can see there's a relatively large gap here, more than my hand span. This would be the major groove, and there are several bases that are accessible in the major groove. By contrast, the minor groove, which is less than my hand span, is much smaller, and fewer bases are accessible. So a lot of DNA binding proteins, transcription factors, bind in this larger major groove. Okay, DNA strands are anti-parallel, which means they have a direction. One strand goes in one direction, another strand goes in the opposite direction. And we give this a name, 5' and 3'. So if that strand's running 5' to 3', by definition, this strand will run 3' to 5'. Now if you ever have to work this out, take a look at the ribose sugar. Okay? The ribose sugar gives you a clue because it's shaped like a pentagon. This is the 5th carbon, and this is the 3rd. So if we take this to be the base, A, T, C or G, depending, and start numbering from the base, 1, 2, 3, 4, 5. Okay, so here the pentagon top is pointing up on the 5' to 3' chain. In contrast, in the other strand, the pentagon is pointing down, and that's the 3' to 5' strand.